Chapter 4.2, log form. We have two forms here. We have log form, exponential form, interchangeable. Make sure that you guys know that b to the x equals b to the y equals x is how we do that. I'm giving a quick form here because you guys have already heard it. They're inverses of each other when you switch x and y up here. And it's log base b of x is y is how you read that. So, moving on, we need to switch the forms back and forth. So again, write this on top of your paper, the switching from log form to exponential form, and I would like you guys to switch log base 10 of 100,000 equals 5 into exponential form, and log base 2 of 8 equals 3, and then switching to log form, 2 to the negative 3 power equals 1/8, and 5 to the r equals s. So they're not always going to give you numbers. They may just give you variables, and you'll have to switch back and forth. But at least in the beginning here, we're giving you guys numbers that are actually true. Would you guys agree that 2 to the negative 3 power is 1/8? Okay? That means when I switch the ones with numbers, the logs, to exponential, they'll probably, or should, work as well. And you guys will be able to verify that on a calculator or in your head. So, we'll do the first log and the first exponential one together, and then I'll have you guys switch the others on your own. So, if I'm working with the log base 10 of 100,000, it's going to be, according to here, I need to switch to exponential, b to the y equals x. The base of that log is 10. So we're going to be 10 to the 5 equals 100,000. And is that true? Yeah, it's 1 followed by 5 zeros. It works. Let's go to the third one down. 2 to the negative 3 equals 1/8. I think it's actually easier to go from log form to exponential versus backwards, but you still should know how to do both. Notice that something does stay the same. Log base b, b to the y. The base is always the same. So, I'm going to start off with log base 2, and then it's always thinking of that the log is equal to an exponent. So the log itself, I'm skipping over the number that goes inside, should be equal to the exponent, which is negative 3. So the number of 1/8 goes inside. Because remember, you're thinking, 2 to what power is 1/8? Oh, it's negative 3. Brings it to the bottom. 2 to the third power is 8, so it's 1/8. I'm going to pause the video. I want you guys to fill in the other two blanks. So, what's the first exponential conversion? What do you write? 2 to the third equals 8. Is that true? Awesome. And switching the one with some letters and variables and numbers and all these different things. Log base of s equals r. A 5 and the s look a lot alike, but we got it switched. Any questions, guys? Not too many, as long as you don't get the form mixed up. Easy enough. It's easy enough to mix up, too. Okay, this is the biggest thing right here. This is going to be the big part of today, and it is graphing log functions. Now, I have said that logs have inverses that are exponential. When you say exponential or hear exponential, you're like, hey, I've dealt with exponentials before, hence just last lesson. I can graph those. I can graph them in transformational form. I can move them left, right, up, down, stretch them vertically, horizontally, all of those things. So, what I propose then, to to graph a log, instead of having to come up with a new parent and putting new points down and figuring all this stuff out, why don't you just take a log, switch it to exponential, find all your information about the exponential function, and then switch back as an inverse to the original function. Can you guys follow that? So I'm going to take an inverse, work with it, take the inverse back to get back to my original. The cool thing is, guys, do you guys remember that if I have a set of points like AB, what's the inverse of AB? What's the inverse? It's BA. So if I can get a set of points, those things underneath the parent, family, and child, name, an equation, all I have to do at the end is switch them. The x and y coordinates to switch. So this hopefully should make it go a little bit easier. Okay. The biggest thing is following those steps of finding its inverse. Switch x and y, and then switch to exponential form. Or vice versa, switch to exponential form, switch x and y. You're going to graph the exponential using PFC, parent, family, child. You're then at the end going to don't graph it, but take the inverse, bringing us back to the original log, and graph that set of data. It seems like a lot of work, but it's the same amount, just one extra column and an inverse. Now, to find an inverse of a log, there's a couple problems or a couple things you need to worry about. One of them is the log has to be isolated to itself before you can switch. That's number one. Number two, I can't think of it, but the main thing is they have to be isolated. This problem here in part A is already isolated. So, one thing I guess I would do on this problem is I wouldn't leave it as f of x. If I'm going to switch inverses, I'd like to see x's and y's. So maybe your first step, maybe that's the problem I was thinking of, is y equals log base 3 of x. Switch it to y equals. Because now when I say switch x and y, it makes more sense. Remember, the inverse of a log is the exponential. So if I switch x and y, would you guys agree that it'd be x equals log base 3 of x? Switch forms, what do you get? 3 to the x equals y. You now have a new function we would call the inverse. Do you guys know how to graph that? I would hope so. Here's the thing, guys. As an exponential function or even a log function, that's considered a parent. Now remember that most of the time parents are exactly the same every single time. If I ask for a quadratic, x squared is the parent. There is no other parent. A square root is a parent, right? They never change. You can always use the same exact numbers every single time. But when we do exponential or logs, the base changes to some other number. But you just need to remember that as I'm going through my parent, family, child, there are 3 pieces of information that I only need. Asymptote, 0, 1, and 1 extra point. And if you know those things, you can graph these. Those are the 3 things that are going to be carried out. So the parent, then, really the inverse parent, right, is y equals 3 to the x. I need y equals 0. I need what point? 0, 1. And I'm going to plug in an extra point. What will it be? This is growth or decay? It's growth, so I'll pick a point on the right. So I'll put in 1. If I put in 1, I get a 3. Hey guys, do I need to go any further? Technically, no. This does not have any moving parts. There is no H, there's no K, there's no A or B, as in the horizontal stuff, right? Therefore, at this point, you would be like, I'm done, I'm ready to graph. But this is the inverse. I don't want the inverse, so guess what? I'm going to make a column and go back the inverse. So I'm going to go back. Y equals log base 3 of x. I'm not going to do all the work. I already did that. That's already given to me. But here's the cool thing. I'm just going to take my data that I just created and do what? Flip them. Switch x and y. So it's not y equals 0, it's not 0, 1, it's, and then you're going to graph that. You graph that, you now have your log equation or log graph. 1, 2, 3. We switched them because originally we switched them. We originally switched them because we recognized that the inverse of a log was exponential, and we know how to deal with exponential graphs.
But then we have to redo it.
Then we have to put it back to log form to officially graph the log one and not the inverse. Okay, so x equals 0. Vertical line at 0, so that means it can't cross. It means it's going to be on one side or the other. 0, 1, or 1, 0, sorry. There, and 3, 1. There's your log graph. Now, I'm going to change my colors, and I'll graph its inverse. What should be true about the inverse? It's the reflection or symmetric about y equals x, right? You remember that? There was that whole thing about y equals x because you're changing y to equal x. They're symmetric. The red one's the one we want. The purple one, that's just extra fun stuff to put on there. The next problem's not going to be as nice as this one. We're going to have to isolate the log. You're going to have to make sure that you have it in the right transformational form when you have it in exponential form. And then, but at the end, you still switch it back. Are we ready to switch?
Yeah, let's go.
All right, try this one on your own. Isolate the log first. Okay, guys, I got to get the log by itself first. So how many people said, hey, I'm going to get rid of that 1? Well, first, and I'm going to get rid of the 1 and change it to y. So y minus 1 equals 2 log base 3 of x minus 2. My next step, I'm going to get rid of the 2 and change x and y. I forgot to change x and y first. Is that okay?
Yep.
So now we're going to have x minus 1 over 2 equals log base 3 of y minus 2. I'm going to change colors. That seems a little light. So does everybody see that now we have changed x and y and isolated the log? We are now allowed to switch. So when you switch now, what do you get? 3 to the? Yes. Equals y minus 2. And then you got to get y by itself by adding 2. So y is equal to? Right. I'm going to fix this because do you guys agree that x minus 1 over 2 is not our proper transformational form? I need to get that 1/2 out front. So it really should be 1/2 times x minus 1 plus 2. So the base is 3. There is no a value. The a value is 1, right? If you think about this is a not a quadratic, sorry. This is an exponential. A's out front is 1. Doesn't affect anything. But we do have a b value of 1/2. The b value of 1/2 will do what to my graph? Horizontal stretch of 2. And you're going to go 1 to the right and 2 up. So now we can go through our steps. Y equals 3 to the x. That's our parent. Y equals 0, 0, 1, and 1, 3. We just did that on the last page, yes? Fam. We said what was going to happen to the family? Horizontal stretch of 2, which means I take all of the what and do what? Multiply all the x's by 2. That'd be 3 to the 1/2 x. Which means, wait, y equals 0 is not affected, is it? Is 0, 1 affected? Nope. I mean, you don't see a change, do you?
Right.
It is affected, but you just don't see a change. And 1, 3 becomes 2, 3. Multiply the x's by 2. We now go to the child, which is the whole entire inverse equation. That's a bad equal sign. And we said we were going 1 right, 2 up. That means I add what to what? X plus 1, y plus 2. So now it's not y equals 0, it's y equals 2. It's not 0, 1, it's 1, 3. It's not 2, 3, it's 3, 5. We now need to go to our inverse, which is back to the log form. I'm putting log form just because I'm running out of room. What would the last column look like? X equals 2. 3, 1. And 5, 3.
So
5, 3, 3, 1, and x equals 2. And there's your graph.
log form is just the original.
If you guys don't believe your work, and if you did it right, go back up to our original problem and put a 3 in. What's 3 minus 2? 1. Then you'd have to take log base 3 of 1, multiply by 2, and add 1, and you will be at 1. We don't know how to do that yet. So unfortunately, it's a little harder to check your work. We will eventually learn how to evaluate logs that are not base 10 or base E, because those are on our calculator. That's for tomorrow. Okay, guys, your homework is page 356, 5 through 8, which is switching the forms. 51 and 52, I want you to use the parent, family, child to graph those logs. Have a great day.